Good morning, guys. Welcome to Algebra today, and today we're going to talk about hyperbolas, which is probably my favorite of all of the conic section shapes. They require a little more work than some of the others, but I think that the results are worth it. Hopefully you think so too. So today we're going to get started as usual with bell ringers. Go ahead and do these problems in your notes. Then have two volunteers go to the board and put their work up on the board. We'll compare our answers in a minute, so go ahead and pause the video till you're done. Okay, so the first one says find the foci for the equation of the ellipse, then graph the ellipse. So what we're going to do is we are going to start off by getting this in standard form. So I have to divide by 64. And what I'm going to get is x squared over 64. When I simplify this, I'm going to get y squared over 16 equals 1. I need to find the foci, so this is my a squared value. This is my b squared value, and we're going to have, for our foci, I'm going to have c squared equals 64 minus 16. So if I'm doing this, then what I'm going to get, 64 minus 16 is 48. And then when I take the square root of that, I'm going to get something like, it's going to be about 6.9 because it's super close to 7. So my foci would be, in the same place as the x coordinate, since that's where our a value is, so it's going to be plus or minus 6.90. So I'm going to graph those points on my x-axis. And then I'm going to graph my x and my y coordinates. So my x coordinates are at 8 and negative 8. My y coordinates are at 4 and negative 4. And then I'm just going to kind of sketch this. So it's going to look something like this. Not terrible, but not great. So it should look something like that. Second one says write an equation of an ellipse with foci of plus or minus 14, 0, and covertices of 0, plus or minus 7. So this is my c value. This is my b value. I'm going to have c squared equals a squared minus b squared. So 14 squared equals a squared minus 7 squared. So we're going to get 196 equals a squared minus 49. But I'm going to add 49 to both sides. It doesn't want me to. So when I do that, I should get a squared equals 245. So I'm going to write x squared and plus y squared equals 1. My covertices are in the y coordinate, so I'm going to have a 49 underneath the y coordinate. And my x squared would be, underneath that would be 245. And that would be my equation. All right, so let's look at hyperbolas. So hyperbolas are kind of cool because we have our vertices still, a vertex here and here. We have a co-vertex here and here. And then instead of making an ellipse that connects those 4 points, it kind of does the opposite. It says we're going to have two outer facing parabolas, like so. Get rid of those. And you can see kind of some of our important information. This is what we need to know, is that the standard form of a hyperbola is written as either x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared equals 1. So there's a couple of similarities between ellipses and hyperbolas and a couple of differences. The big similarity is that they still both have to equal 1. In standard form, they have to equal 1. The big differences, though, are that ellipses had plus in the middle and hyperbolas have minus. And in ellipses, the a and the b were the ones that switched. It always went x, then y. But here, it's going to be the y and then the x that change. So here, if it's an x squared, y squared, it's going to open like this. If it's a y squared first, it's going to open like this. A is still the greater value. It's just going to be that we switch the x and the y around. Okay. So we have vertices then at plus or minus a comma 0. And yep. So let's just jump right in. Graph the hyperbola with the equation y squared minus x squared over 9 equals 1. So I'm saying, okay, my y squared comes first. So if y squared comes first, I know that it's got to open like this. So what I'm going to do is I'm going to find my a and my b values. So a would be 4, b would be 3. Plus or minus 4 and plus or minus 3, sorry. And I'm going to graph those points. So on the y-axis, I'm going to graph 4 and negative 4. And on the x-axis, I'm going to graph 3 and negative 3. And this is why I like this so much, you guys. Okay, so we're going to make a box. So I'm going to use a dotted line to kind of make this box. I'm going to fill it all the way around. And my vertices are here and here. So next, my next step is to draw some diagonals. I didn't think I had a straight edge. Okay. I'm going to draw a diagonal that goes from this corner through to this corner and beyond, okay? And this should pass through the origin. So I'm going to turn it, or draw it like that. Okay, so there's one, and I need to draw the other one. Going through both corners and through the origin. And what this does is it gives me the shape for the hyperbola that I'm graphing. So I know that it has to open up or down, so my only step left then is I'm going to start at my vertex, and it's kind of like diagonal asymptotes. Like they are points or lines that kind of guide our hyperbola, but that our hyperbola can't cross them. They're like those electric fences that we talked about that it can't cross, but it can get really close to. And that's it. So our A and our B values the B values never touch our parabola, or our hyperbola, excuse me, but they help provide the box that gives us the guidelines to our hyperbola. So let's try another one. Oh, find the values of A and B, graph. We did that. Hello. Okay, next one. Graph the hyperbola with this equation. First thing I notice is that it does not equal 1, so I need to fix that. I'm going to divide by 64 on all sides of this. 64, 64, 64. Here, when I simplify that, I'm going to get x squared over 16 minus I'm going to get y squared over 4, and that's going to equal 1. So my first step is to find the values of A and B. So A would be the square root of 16, so A would be plus or minus 4. B would be plus or minus 2. And this time, because x comes first, this is in the x-axis, and this is in the y-axis. So I'm going to have 4 and negative 4, 2 and negative 2, and I'm going to draw my box. Then I'm going to draw my asymptotes, or my diagonals. So that's going to look something like this. And then drawing the other one. like that. And then my final step is to sketch the graph. Since x squared goes first, I know that it has to open outwards, so I'm going to start here and get close to those asymptotes, but I'm never going to cross them. So yeah, I like these because they are just they're kind of fun to draw. You just have these grid lines that you're filling in, and it's quite aesthetically pleasing in the end, I think. So next, we talked about the foci of an ellipse, so today we have to talk about the foci of a hyperbola. So think about, yesterday we talked about with an ellipse, it was c squared equals a squared minus b squared. Today it's going to be the opposite. So it's kind of like ellipses have the plus in the middle for their main, or their formula. And today we're dealing with like x squared minus y squared. So the signs for the foci are always the opposite of what the sign is in the equation for the conic section. So to find the coordinates of the foci, we use the Pythagorean theorem. We just do c squared, and this time instead of doing a squared minus b squared, we do a squared plus b squared. Find the foci of the graph, then draw the graph. So I know what my a squared is. I know what my b squared is. So I'm just going to do c squared equals 36 plus 4. When I add those together, I get c squared equals 40. And then, if I want to simplify that even further, and I want to find what's the square root of 40, I can do that, and I would get that it is approximately 6.32, plus or minus. So the foci would be, because it's in the x-coordinate, it would be plus or minus 6.32, comma 0. And I'm going to go ahead and graph those points. So it's going to be a little past 6, not quite 6.5. It's kind of an estimate though. And then I'm going to graph my other points. So I'm going to have the points, A is going to be plus or minus 6 in the x-axis. And B is going to be plus or minus 2 in the y-axis. And this time, notice what's happening is that our foci are now located within the kind of those parabola curves instead of being inside the box. And that's what should happen. When you find your foci, they should be outside of the box. Because the box is not our graph. The box is just our grid lines to help us find the shape of the parabola, or the hyperbola, excuse me. All right, so then I'm going to say, okay, I already know where it has to be x squared, so it's got to open left to right, so it's going to open like this. And that would be it.